Oh, my computer died. That's okay though. That's just how life is. Hey there, OBS. Bang. Oh. I got a dog pony. And it's gonna test. Cool. Cool. So let's go ahead and run up SRC, and I think let's start with just getting like a simple processor up and running, right? So let's just make a main. Oh hush. Control main. Okay. And there we have main. So if we open up the MD, so we got Verilator working. Before slide into the FPGA. What's the so what do I have left to do? Simple instruction decode. Yeah. Instruction decode. And then we're gonna have instruction fetch for the leader. Need the 32. Alright. Let it go. Okay. Now let's put the 32-bit. the base instruction set. Reference, and then let's open up the PDF. Okay. Okay, so let's see, we have R type, I tape, S tape, U tape. Where do they show the values for the instructions? Okay. Um, Okay. Is it immediate 5 too? I think so. Okay. So what do we need? We need to have a logic 6 wide opcode. Right. We have a logic 4 5 wide. My brain is shutting down. But we need to have destination register, source register 1, and source register 2. We also need to have our and our and then they're going to produce an immediate 32-bit value, right? If they have an immediate. For all the instructions, we can begin like this, right? Always come begin and end. We know that opcode is going to be instruct the input. Let me put input in. Okay. Input logic 31 to 0. Let's call it instruction. So we just need to have this I from 6 to 0. Right? Yeah. And then we're gonna add a decoded instruction type that has the body pointers. Parameters 2. Okay. So we need to create some sort of decoding type, right? Let's see, how are we going at this? Let's just start with the package, how about that, right? Let's put the package below. No, let's put it above. No, let's put it below. Let's put it above. Let's put it below. I don't know. Let's put it below. Package. RV32 decode. And package. Okay. So we know we have our instruction formats. We have R, I, S, U. I know there are more. Let's just start, right? So let's make ourselves an enum, type def enum logic. I don't know how many to put. It should work for now. And let's just call this inst fmt kind, right? And then we're gonna have format none. It's gonna be equal to 3 decimal 0, 0. You suck. Okay. FMT R to. Do I even need to give these values? I don't feel like I need to. They should assign themselves, right? FMT I FMT S FMT U. Okay. So now we have some instruction formats. Where do we find all our opcodes? You give me the opcodes, brother. Where are we gonna find these girls? Gonna have a night? Lit, brother. Oh! Okay, I don't think I'll be able to synthesize a 32-bit first computer on my little tiny terrible FPGA. I only have an RTX 7. So we're gonna get around this by just making a 32-bit processor, which is like fine, whatever, who cares. I would need 64-bit anyways. Yeah, 4 GB of memory. I don't even have that much memory. Like, it's fine. Why is it so annoying to find things in this instruction manual room? Why is this so annoying to find? So this is the system opcode, but like, how do I find that? There we are. Okay. So it looks like there is also a FMT B type, FMT U type, FMT J type, and an FMT ammo type. Don't know what that is. Let's make this a 3 again. Cool. Okay. This isn't even a good way to write this. I don't know. Okay, let's do this differently. Nobody cares about these. Well, let's just leave them already anyways. Okay. Let's do type def enum. And let's call this. This is just the instruction. Kind. Bang. Simple. Easy. Okay, fine. Logic. Should be back by now. Okay. Add inst sub and shift right arithmetic. Yep. So less than inst set less than zero extended. Yeah, whatever. We can just add that back later. Addy, XORE, Ori, Andy, Slee, Sreely, Sry, Slee. Oh, branch equal, branch not equal, branch less than, branch less than, branch greater than. Chow, Chowler, Loy, UIPC, Call, break. Bang. Bang. Error. Is that really all of them? What about? You're pretty. Whatever. So here we have crazy background. All right. Okay, I'm gonna try to write functions. This will be my first time writing functions. So this should be interesting. Okay, primary purpose of a function is to return a value that can be used and cannot parallel cast functions. I didn't know this, girl. Hot diggity. Okay, we're just placing the repetitive code in function. Okay, so it's like what I used to use macros for. This is ridiculous that I never learned this. Okay, let's fold this. Oh, so glad that works. Okay, cool. Oh, and that is beautiful. Like the code formatter doesn't unfold. That is not always a given. Okay. So it goes function, return type, name, params. Okay. So that's how one writes a function. So what instruction format? Oh, okay. So we're gonna have a function, our return type is gonna be an instruction kind, name is gonna be val, get kind. Parameter is going to be opcode. Good. Type diff. And then we should just be able to let's change it how we're gonna do this. Okay. Let's make a type def packed struct. That's not right. Is that not just packed? Or do we put it after struct? Packed. Okay. And let's just call this decode inst coded. That's a type. Okay, cool. So, what do we should put in here, right? We should put if it's valid. We should put if it's illegal. Cool. Type def logic. Let's call it rage ID. So then we're gonna have be done. I'm an adult. It's, wow. I'm learning so much and it's probably not good for me. Oh, these surely are semicolons, right? It's a struct. Decode reg -1. Decode reg -2. Okay, cool. Let's see, what else do we need? Let's think about this. Okay, yeah, let's add a raw. Logic 31 to 0. Let's call it raw. let's just throw in the formats, I guess. Okay. Kind, which would be the I guess it's the operation. Format kind. Let's just call it format. Is that not what it was called? No, it's just called inst kind. Okay. Ridiculous. I'm sure there'll be more that we need to add to that later. That's all right for now. Okay, let's make a function that just admits that. So let's do a function that returns a inst decoded type. Its name is called init, and it comes from is this right? Okay. Okay. So let's make a new inst decoded type. Right. Let's call that inst. And then inst is equal to 0. I remember system verilog. Inst.raw is going to be inst input, right? Yeah. Inst.valid is going to be fine 0 as okay. Let's go back to this type. Okay. Do I have an invalid in here? I do not. Let's add invalid. Inst invalid. It should be called op, or should it be called inst? I don't know. Whatever. It doesn't matter. Let's change this to inst though. Inst.inst. Inst.op. Okay, yeah. Inst.op is equal to inst valid. Yep. Hence.immediate is going to be equal to 0. I mean, we're already using our input, right? So, like, we could set some default value. No, let's just keep everything at 0. Like, it's fine. Okay. Cool. So now we have this function, and then we're going to just return ints, right? Beautiful. Okay. So now we have an instruction. So what we should do now is decode our kinds, right? I think so. I just saw something that I could use for this. I don't remember what it's called though. What was it called? What were you called? What were you called? I guess we already know our opcode. Let's just put that in, right? Why not? Like, it doesn't matter. Logic code. It's in the raw. Why am I like? This don't need to exist. This is just wasting more space. Like, we know where the opcode comes from. Oh god, bro. Brain melted. Okay. Unique case. That's what I just learned about. So we're gonna put unique case on opcode. Begin, end. Okay, we don't need begin. We do end case. Okay. Now we need things for the opcodes. Is there a default? Yeah, there is. Okay. Default. Begin. And How do you do? Wait. System. Display command. What to use? All right, bro. Oh, where am I? Yachty. Shadow Cuddy. Okay, yeah, let's use hex. So encountered opcode %h. Which we don't handle. And then we're gonna just stick an opcode, right? I hope so. That'd be cool. Right. So opcode. Let's see. What were we thinking? We should have ourselves one of the inst decoded type let's just read inst. Why do not exist? Because I need to import the package, which is something like import package. What do we call a package? I think this is the syntax. Import, so just like that. Import in unit scope. For declaration, but I'm importing it here. Whatever, okay. Okay, cool. So inst is going to be set to be equal to I should call it a net. There's no way to call it. Just call it a net. Okay. Just call this a decode inst net. I don't know if this is going to work. And then we're just going to pass in our inst I. Right? Cool. Zion Maniac. I forgot to say, but I'll add you on Discord in a bit. Sounds like fun. Though I think it might be only you in this one. Encountered opcode %h. Yeah. Okay, cool. so we need to make a test bench, right? So let's work on that. For this, we're just gonna want it to print out that we encounter an opcode that we don't know. So let's open up our to-dos. Instruction decode. We want to implement each opcode's decoding stage. Step in the implement each opcode, and that's going to be possessive. Each opcode's decoding step. No, whatever. Okay. Let's figure out how to write a test. We're going to test, and then we're going to add a new test folder. We're going to call that decode. And we're going to call the test itself missing opcode. System Verilog. Okay. So that was the name of a folder. Okay, decode, and then we're going to create a new file, and we're going to call that missing opcode. Okay. I wish I could fold this. Okay, yeah, let's just module missing opcode. I guess it probably should have a TV after it, yeah. And then module. And then just need to add the there. Very cool. What's wrong with you, buddy? Actually. Very cool. So let us go ahead and import. Oh, did not mean to mark that. It's okay. Okay. It's okay that you can't find that. We're just gonna hope that Verilator can. We're just gonna do initial begin and decode module, right? Because it's called decode, and the module name is decode. So decode, and we're gonna call it unit under test Who cares, bro? Who cares? It doesn't matter. We need to make a logic 31 to 0. I'm not going to call that inst immediate. And then dot inst I is going to be inst immediate. That's how that works, right? Yes, that is how that works. And then instead of our initial begin, we're going to set inst I to be equal to 0. So theoretically, this should print out what we need. So let us go and work on our makefile. Set of tests, set a makefile. Let's run test decode. Which will obster binary j0. Okay. So how does this work again? So source files. We pass in our source files. So I'm just gonna pass in all my source files and then hope that it figures it out, right? So let's throw a wall in. No, let's not throw a wall in. We need to add in what is the file called, dude? src decode. Okay, so src how does this work? Am I a fool of a toque? I might be. Okay, and then baster. We're gonna have a source dir slash decode slash decode v along with test decode slash missing and then of course we're gonna run a nothing after that. Let's just see if that works. So let's run make and this is inside the testing makefile. So let's go into the other makefile and test decode. Decode. Make. Okay. I'm missing an instruction inside of missing allcode can't find definition variable. Oh my god, it's logic. I'm an idiot. Okay. Tests code. Okay, violated. Okay, so let's open back up this one let us run. What did it build as .html code? I'm not sure. Okay, so we got a decode, but do we have... What else did we run decode? Okay. And if we change this to yeah. And that goes again. Oh! Bada bing, bada boom. Okay, I don't really understand why that is, in fact. Is it because it's the test bench? I'm not sure. That would be great to know. Interesting. Okay. So let's open up that make file again. Yep. Missing opcode test bench shout out. Okay, house. Ooh. Weird gas in my stomach. Okay. Got a little bit distracted. Let us run the test. I encountered output 11, which we don't handle. Cool. Okay. Let's also add references. Yeah, let's call it references. System Verilog. Synthesizable code. Let's just look at Verilog. Bang, function synthesizable code. Oh. Alright. We added back the references that I used so far. Let's kill that buffer. Okay, let's kill this buffer. So that is actually parsing the opcode. So let's go back to source decode. Okay. So we need to finish implementing the decode code. So let's make these opcodes exist as, I guess, local params. Probably be a good way to do it. So let's do package root and let's do local param. Just make an opcode type. I should just make an opcode type. This is my problem. I just want to like type def everywhere. It's like my favorite command. Yeah, dude, I'm such a mess. Okay, cool. And then local param opcode type opcode. Now I need to find the opcode. So let's open back up that buffer of what was it called? It was called risk. I'm privileged. come back with that instruction table, I guess. Okay. So, opcode E is equal to 7B apostrophe 111 double naught double one. Yeah. Okay. Cool. Wait, that's whatever. Let's stop thinking so much. Okay, opcode LUI is O11 O111. Opcode AUI PC is double naught 1 triple naught. Let's just make this easier. Chower. Okay, what is it? Branch is double one double. No, it's just two. Store is load. Immediate. RF. Okay. What else did I have? We're talking about. Oh, dang it. Okay, let me just get rid of these. Cool. Format that. Beautiful. And now we just gotta use them. So let's copy this girl over here. Okay. So we're in our always cone, and then we're switching on these opcodes, and we just set the opcodes. So let's start with the simple arithmetic ones, right? So do we just do opcode And then surely we begin end, right? Surely. Literally end. Okay. So we can see now that we're in our arithmetic, opcode arithmetic, and all of these are of the R format type, right? So we know that we can do inst dot fmt is equal to fmtr. That's the first thing we know. And because they are of this format type, if we open up here. We don't know if it's valid. It's still illegal, right? We know what RD is going to be though. So inst.rd is going to be between bits 7 and 11. So it can be inst I 11 to 7, right? And then we know that inst dot rs1 is going to be equal to inst I from 19 to 15, and we know is that right? Yeah. Let me download this so I can pull it up. Projects. There. Okay, yeah. So rs2 is going to be equal to inst I from 24 to 20. Okay. And then we're going to use func3 and func7 to determine the rest of the parameters for the type, right? So we still have so these three are done, immediate is done. We need to figure out what the actual op is. The immediate is not done. I'm lying to you right now. It's because there is no immediate. He's crazy. Yeah, we should need the opcode. So inst dot op, we're going to set in another unique case. So case for what is func3? Yeah, so is this worth doing or is this not worth doing? Oh, funct. This function fun doesn't work. Func3. 3 is equal to inst I from 14 to 12. And funct7. Okay. That is all of that information. Surely I didn't put the opcode in there, right? Better than that. Okay, then we have a unique case on funct3. begin, end. Nope, it's end case. We're gonna have default, begin, end. And we're actually gonna change this other one to an error instead of a display. Because we want it to error out if we're encountering opcode we don't have implemented yet. So inside of func3, let us start with func3 being 0. So case 3 x0 begin and end, right? Okay, yeah. And let's just duplicate these a couple times. So we have 4. We're gonna have 6. We're gonna have 1. We're gonna have 2. We're gonna have 3. We're gonna have 4. We're gonna have 5, 6, 7. Okay. Okay. So if there's only 3, there's only 8 values, we don't need the default case. Yeah. Okay. So if funct7 is equal to 7vh00 begin end, else if funct7 is equal to 7h20 begin end, else begin end, and we're going to error invalid funct7 in our type instruction. So we know if it is a 0, that inst.op is going to be inst.add. And none of that's all. And then inst.op is going to be inst.sub. Cool. So if it's h1, that is a shift left logical. So let's grab this. Structure. Pop that in. Pop that in. That sucks. h1, if it's equal to 0, r 0. Check out logical. Okay, h2 is shift less than. Three is z less than. No, z less than upper. 4. I should put the 3 in there. Okay, whatever. 4 is XOR. Five has 2, which is shift right logical and shift right arithmetic. Good enough. Cool. 6 is alone and it's OR. 7 is AND. Okay. That's all of them. So let's update this error message to be something a little bit more informative. So, error, invalid func 7 and R type. Func 3. Time. Weird. Okay. Another way. Oh, fold them is so nice. Oh, I guess not. Okay, whatever. That is that instruction done. So now we should know what the operation is for those. Let's do the immediates next. Okay, opcode. arith, no, we want immediate. Begin and are these the same, actually? That'd be interesting. No, because they actually use immediate values. So how do they do this? Oh, one, two. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2. You have 2. I think we've hit the wall for the day. Okay. To do MD. Okay. Implement each optic goes decoding step. So we have arithmetic, immediate, these. Let's copy a one of these. Those in. Go. So we have add sub XOR or all those are done. Cool. Other things I want to do is multiple instructions. Or, well, I guess these are just, we could call this multiple. So it's not actually the full decode step. We need to do memory. The system learning. How packages were to structure them. which is from the Duo assertion system parallel interferences. Assertions. What do we call that? Okay, cool. I think that's everything. So let's stage these files. Actually, let's go into you can ignore this. Stage. Cool. Scope is as selected. For using the relation to builds and tests. Color, just getting used to the tooling rather than anything too huge. Cool. I think that is going to be all for today.